Hello, hello. Can everybody hear me? Welcome everyone. Please, please take a seat. We are about to start in 1 minute. Okay, warm welcome to all of you here. I think this is the third time we have an event especially for architects in 3D printing. I am one of the founders of 3D-UTSKRIVNA from 5 years ago and also the CEO. And I'm happy to welcome you to Patrik Rosén, who started with us this spring, who will tell you a little bit about today's agenda. Yeah, I hope you will enjoy it.
Tack. Jag kan lägga den där på bordet. All right, welcome. Just a short image showing the schedule for today. You had a coffee, I hope, and some breakfast or second breakfast. I will start to do a pretty short presentation regarding 3D-UTSKRIVNA and what we do. After that, Jonas will follow up with a presentation, and Negar after that. At 8:30, we'll have an open question session for everyone. I will have a microphone since we are going live on YouTube and recording this. When you have a question, just raise your hand and I will try to run around with the microphone and hold on with your question until you get the microphone, so we get the voice out on internet. Oops. Yes, so 3D-UTSKRIVNA. We are situated here as our main office. We also have a smaller office down in Malmö. We work with knowledge and solutions when it comes to 3D printing and additive manufacturing. We're focusing on both architecture, but also the industrial world of 3D printing. So our vision is to make additive manufacturing and 3D printing the most value-adding manufacturing method and technology of this century. 2014, Daniel started 3D-UTSKRIVNA together with Anders. And today we are over 20 people, I think, today, or 21, yeah. So we've been growing pretty quickly, and it's been a great journey, and I joined this spring here. So we are mainly a distributor of 3D printers from Ultimaker and Formlabs. And the last brand we added was Markforged, which I'm the sales rep for. So that's kind of why I started here. And lately we've just also got an agent deal. So we're selling HP machines as well. And they are doing the multi-jet fusion technology. So we have all kinds of technology in-house. We also have this 3D Meetup Center that you are sitting in now. So this is our showroom and Meetup Center, which we share with a lot of different companies. Who you can see the models on the stands here. So it's also possible to use this area as an area for workshops. So if you have a big project with a customer, it's possible to rent this location and do something in cooperation with us. So we also have a new department here called 3D-UTSKRIVNA Studios, where we do 3D printing, 3D scanning, 3D design, and consultancy. We started this before the summer, and we have roughly 15 years of working with architecture. Myself, I've been working with architecture for since 2000 mainly. I've been doing 3D visualization and illustrations. That's how I got into the 3D printing. And the last 6 years I was working in architecture. We also used 3D printing a lot. It's a great way for you to start test 3D printing if you don't have a printer in-house already. It's a good way to start experiment and see what kind of printer do we need, what kind of use would it make in our world, so to speak. So it's a good first step into 3D printing as a technology. And we also work a lot with helping companies with the complete strategy regarding 3D printing, not only just sending printers and telling you how to start it, but how you actually work with files, how you get the workflow into your daily work at the office, for example. So that's a consultancy part. Yesterday we launched our site regarding this, so you can visit our homepage, and if you look at tjänster or services, you can find this page. So we try to list the services that we offer with some use cases as well, which we've done so far. That's the complete address if you want to jump directly into it, but you can also find it on the web page. All right, so that's for me. That's everything for me. I'm going to bring in Jonas to start his presentation.
Thank you, Patrik and Daniel, and thanks for inviting me. I'm Jonas Runberger. I'm working at White, where I'm heading a team working with many different versions of the digital and computation, but I'm also in academia, currently a professor at Chalmers, previously at KTH, and I recognize quite a few faces from my time at KTH here. So I'm going to talk a little bit about how we use 3D printing as in model making at White right now, but I'm going to shift gear to following what Daniel said, or was it Patrik, or both, the vision for the future in terms of additive manufacturing. So of course, as I'm sure in many offices right now, we have our in-house printers, we use them in different projects. I usually say that today we do many more physical models than we did 10 years ago, and the same was true at the universities and the architecture schools when laser cutters and 3D printers came. And I think that's really important to do many versions. For instance, in urban planning, this is Veddesta project, or Roslags Näsby, where of course we can represent our projects to clients and so on, which I think is sort of fully now immersed in practice. Also in smaller scale to work out detailing and so on, in places where you actually have to break down the models into many different pieces, or in combined composite models where you don't just 3D print everything, but you use different techniques and you put them together. But we also try to challenge ourselves in our designs. So this is an example of a, hopefully in the future, masonry wall or brick wall for Höganäs as a concept study. Of course, we can check again many different versions based on our computational models. And in this case, something that will most likely not be 3D printed in the end, but it's an artistic piece by Ebba Mats, the artist at Klemostoren in Lund, to test also not only the visual aspects, but sometimes also the structural aspects. Here's another example where we start to use the different material types of printing in this timber construction for a climatized courtyard space called Eco Canopy, where we also try to simulate the translucent roofscape of this project. Or here, where we start to see challenges in our sort of rapid model making for this wooden bridge. The grains of this wooden bridge will not follow these lines, as you see in this model. So there are different challenges also in terms of representation. This is maybe one of our most tricky ones. These sticks are meant to represent straws from this competition project of a pavilion made of straws and hay. So we're still working on that. But it's interesting to see the challenges and the opportunities in the printing technology for materiality. This is a concept study originating at the KTH in Marwell there, where color also became an important aspect for this roof, which was supposed to be built up of many different small pieces that in themselves could maybe have been 3D printed. Or in this case, a structure which is really focused on bent material, but in terms of its representation, we use printers to test it, and we do quite a sloppy job of making the greenery at the moment. But and on the right-hand side is a model this high, but in the small scale to test many different variants, the 3D printing aspect is very important. You may have seen this model here, which we were really happy to, let's say in collaboration with tillverkningen, get printed. This is recently completed Forumtorget, where we used dual materials to represent the solid, the opaque materials, and the glass material in this bench, which is lit from the inside. And of course, during the process, we also did many different versions. But it also comes to a point when we realized that in order to understand this project, we actually need to do mock-ups and prototypes. And I'll get back to this because I wish this bench was printed, but it's not. In reality, it's cut from quartz composite and glass, which leaves to material leftover and so on. So this is why I want to bring up the additive manufacturing aspects. This is our own, or some of our own printers in the office. So as you may know, White has several offices, and we try to have this equipment in-house for especially the design models during the design process. But I wanted to shift gear then quickly to near future or current, if you like, and also mention that in popular culture right now, I think it's always interesting to look at popular culture, and you may be familiar with this image if you're following a certain HBO series. It's interesting to see when HBO envisions the artificially constructed entities, people, horses, where they go to is actually 3D printing in a way, and they deposit fibers. So that's where I want to start the second part of the talk. This is from the vignettes, the introduction to Westworld. They even print the iris of the eye with fibers. That may seem far-fetched until you go to architecture, where it's happening, of course. This is deposited fibers in Pavilion by ICD ITKA, who've done a series of projects which deposits fibers, which I would claim is 3D printing also. It's additive, you add material together. You have minimum scaffolding, there's some scaffolding, but far less than the supporting structure in many 3D prints. And this is part of ongoing work that I find really interesting and a huge opportunity. And I encourage you to look up their website where there's loads of materials on that. But we of course know that 3D printing already exists in architecture. We know this, it could look like this if you go to China. And the bottom right is a 3D printed building, at least claimed to be. And I guess my drive in this context is not to go this way, but actually look at the opportunities of technology and production in terms of additive manufacturing, see where you can go. Some of the earlier studies include this. This is D-Shape, Manfredo Dini, doing something which is very similar to a normal powder 3D printer. It's just bigger. but it's put out layer by layer in pieces and building structures that can support each other. Or similar work in concrete. The previous was artificial stone, done by Loughborough University and Foster's. A kind of secret project that we're not sure how far it's gone yet, but making building components with integrated services and so on. Or in this case, this is Philip Block from ETH, I believe a sun-printed formwork for a cast, doing slabs that are something like 60% less material to the same structure. And they also, of course, test them, and they use them. This is part of the erection of a housing unit for researchers, and they're really close to bringing this really onto the market. Other departments at the ETH as well are doing similar tests, where they can really deposit the material where it's needed. So this beautiful pattern is actually a structural optimized slab. And many attempts and different experiments have been done over the past years. This is an example of an earthquake-proof column. This is a structure that would emit heat, of course, maximum surface area, like a radiator. With the extreme here, with the digital grotesque grotto, which goes into somehow a contemporary Baroque aesthetic. Getting closer and closer to actually being used. Maybe you're familiar with the MX3D steel bridge being finished in Amsterdam. I don't think it's in place yet, but it's 3D printed in steel, really welding it layer by layer. And it has, of course, a form that is somehow optimized, but also aesthetic. They actually include sensors to make sure it works. This is a thesis project from last spring at KOADK in Copenhagen, and it's a printed interior wall using very off-the-shelf printers, but these students hacked the printer in a way so they control the depositing. So there was never a solid 3D model behind this project, only the paths of deposition, which I think is one step forward. It actually means that you bring in you kind of generate the G code as you design, the control data. I always have to show this in this context. I think it's a beautiful project from RCA, Marcus Kaiser, solar sinter machine, which completely depends on the sun in the Sahara, of course driving computers and everything, but then using a concentrated sunbeam to sinter sand into glass. And experiments like this in clay, going into smaller units, not a big printer, so it's kind of a swarm principle or an agent-based printing machine for structures. Or now in the current Venice Biennale, you can see the Chinese pavilion with this big pavilion in plastic. Is named Cloud Village, and funnily enough, there's a cloud pergola in the Croatian pavilion, similar principle, maybe a bit more delicate, but the key in these two projects is that it's not printing layer by layer, it's extruding freely in space and quite rapidly building big structures, which also has been tested by others. This is an example from Branch Technology in the US, making the scaffolding and then cladding it. So you basically, you print the rebar of the wall and you clad it. MIT with Nero Oxman and others, material ecology studio, working with many different materials. And also NASA, of course, having for a couple of years had architectural competitions for additive manufactured buildings on Mars. So these are two different phases of this exhibition where you see the Foster second prize down to the right on the most recent to first prize and second prize. Of course, the idea here is that if we go to Mars, we don't bring material to build structures, or at least we minimize that. We use the material existing there, and we print it. In Sweden, things are happening as well. This is very current work by David Andrén and others at the LTH, and they are using pulp from the timber industry and fungus, Thermitomyces fungus, as reinforcement that they grow. So this is sort of a happening here as well. One aspect of this in going up to scale is resolution. Here's some explorations by a student of a European PhD program called InnoChain, where the structure is first printed, then milled for a super exact surface. This guy comes from industrial design and vehicle design, so he needs perfection in surface. With this example, with PhD candidate Helena Westerlind, who's at the KTH, she's also associated to us through this network InnoChain, and she's working with additive manufacturing in concrete. So to wrap up, I just want to say something about what's going on here and a project that I'm involved with myself. This was a thesis project at the KTH from a few years ago, Felipe Franco. And this is a proposal for a floating bathhouse here in Stockholm. And his challenge was that he took on the assumption that you could 3D print in timber using cellulose-based materials. He worked together with RISE, or Inventia, as they were called then, and us at KTH. The material didn't exist yet, so he had to speculate on the structure, but he also assumed this idea that you could extrude freely in space and quite rapidly build up structures. It was actually one of the starting points of this research project called Wood that we're part of, which is starting right now with a number of different actors, including Stora Enso and many others, and RISE. That will explore if we can go to full-scale additive manufacturing with wood-based materials. And now I wish I could show you amazing structures, but we're just starting. So I can show you a chair done by Stora Enso, which is printed with about 30% wood fibers in it and other composites. But this is really where we're going right now. And to the right, you can see also an example from students at the KTH machine design. In a similar way to what I showed you with the fiber deposit, actually having a thread, a paper thread deposited like this. So next time I'm here, I hope I can show some amazing work from this project. We just started. But I wanted to almost done now with this graph, which comes from L Studio. You can look it up yourself. But it's interesting because it talks about 3D printing or additive manufacturing and architecture in the past 20 years. And just the curve here is maybe what's important. You can see the number of attempts happening for the first 10 years. And this is up to 2015. All over the world, there's a lot of tests and explorations in shifting into additive manufacturing. So what you're foreseeing here is happening. It's just not in the industry. It's in the experiment phase. Final image, I just want to do a bit of marketing, if it's okay. There's a conference happening this weekend and Monday, Tuesday next week at Chalmers. Called out Advances in Architecture Geometry with a number of keynotes. It's not focused on 3D printing. It's focused on geometry, the digital, in architecture and mathematics, and 3D printing is part of it. We have 14 different workshops, still seats available in some of them over the weekend, and a great program Monday, Tuesday. So if you're in Gothenburg, or if you can manage to go to Gothenburg, please have a look at this conference. And that's the final thing. Maybe that was even shorter than 10 minutes, but I tried to keep it fast. Yeah? Yes? Well, it's being used already, but not here. Sweden is in a particular situation with our big contractors and so on, but to smaller scale it's already happening, I think. It's just a matter of finding the business model and how to do this. We have, of course, a lot of challenges also with our new materials. When you look at wood, cellulose-based materials, they need to be certified and all of this. But in concrete, it's almost there. No. I think it will be an important part of construction. I think it will allow smaller actors to be contractors and deliver parts. I wish that, at least, so we don't depend on big industries with big factories. We see examples of very small-scale production. So my hope and my vision is really to go back to a situation where we have many smaller actors with advanced technology and a lot of knowledge to contribute to the construction. I'll be around later also for any questions.
While Patrik is helping the next speaker on with the mic, just a little question from my side. How many here is using 3D printers already? Okay. And how many is not using 3D printers? Okay, so a bit half-half maybe. So just interesting to see how many are new. And those of you who are using it, what would you like to see in 3D printing? Is it speed or is it materials or something? Any comments? Speed. Okay, good. Scale. Bigger. Okay. Thanks. Are we ready?
Yeah.
Okay.
Yes.
Patrik, would you like to introduce?
Yeah. Hi everyone, my name is Negar, architect at Link. Amazing research or projects that Jonas shows. Actually, I was thinking the first time I used a 3D printer was at Jonas' studio some years ago at KTH, so it's a big honor for me to be here with Jonas and talk about this. Yeah, today I'm gonna talk about how we work at Link. The logo shows the different offices we have in Denmark, Norway, and Stockholm, and 3D printing. Here is the picture of the office we have. The 3D printer we have is Ultimaker 3 Extended, and the material is PVA, and we use both ArchiCAD, Rhino, and Revit in the office. And then the program for the printing is Cura. It's Ultimaker software. And we print our models up there in a room, a separate room, and then we display it in a bigger table in the office in the big, for our client. When everybody who come to the office, they can see it. So why 3D models? Yeah, because it helps us to easier visualize our idea. And when you have it in your hand, you can see it from different angles. You can touch it. It's more real to have it in your hand. And then it's a strong means of communication in different levels. If you want to communicate with your colleagues or your clients or commune or municipality, and so on. So it helps us for design as a work in progress, really, because when you want to change something in your model, you don't need to do it with your hand. You can always work on your computer and send a new print. So you can always change your design. So it's a work in progress process. And it's time efficient. It's faster models because you don't have to do it yourself. You work while the printer is printing. So it's also time efficient. And it's low cost compared to many other like traditional model making. And the models are durable because you can, if they get dusty, you can just wash them. You don't have to make them like those glass boxes that we used to have before. So, seeing is believing. From the time you have an idea, you sketch it on paper, and then you maybe scan it or draw it in your computer, and then you print it, and at the end you have it as an object. So when you have it as an object, you see you can see the proportion of it, you can see it in a bigger scale, and discuss about it. So from the idea to object. Here 3D print model as a strong means of communication, and I try to show it in different levels. You can, if you have an idea or you want to talk to your colleague, you can have a very basic concept model. It doesn't need to be detailed. So between architect and architects, or architect and clients, or municipality, as I said. So you have something to show because for architects maybe it's easier to have it in your head, but not maybe for your clients. Communication between architects and other consultants. It can be construction, it can be landscape. So it's different levels of. It's really good help. And then even in building site, architects can have the model all the way through the building site and communicate better, easier. Yeah, this building is going to be built there, or yeah, it makes it easier. And then at the end, the developers or sellers, they can see, for example, yeah, the apartment you want to buy, it's here on this floor, so you can see the view or, yeah, what you see from your apartment and so on. So, sorry. Yeah, it's less misunderstanding, because sometimes you're talking about something, but your clients have something else in their head. So it's less misinterpretation also. I'm so sorry. Yeah, link examples. Yes, I'm going to show some examples that we work at Link. Here is a project. It was a competition that we won a couple of years ago. It's Bonniers Kontorhus, Bonniers Fastigheter. It's office building, and it's in Södra Värtan, Norra Djurgårdsstaden. And it's a very high profile of environmental aspect. The aim is to have plus energy building, and then this works as an entrance to the whole area, the new area. It's happening a lot there, and the building, consists of all concert hall, clubs, restaurants, offices, shops, and so on. And all the one who works in the building and everybody in the area can use the facilities. I don't need to go to detail of the project. And here is the model we made for it. This is the last model we hand in to the clients. It's this one. You can see it later, maybe. It took maybe 2.5 days, so it's quite a lot of time. It was a process, because we had maybe 7 samples of this model. Sometimes they were more solid, and we were changing the facade with these lamellas to see the different design. And then here is the model in the Cura, so the interface of Cura when you have your model. The next project is BRF Glitne. It's residential housing, the collaboration with Björk Engels, BIG. It was an additional building to an existing one. It's residential, and BIG was responsible for the form of the building and the facades, and Link designed everything inside to adapt it with Swedish standards for apartments. And so we did this model in Stockholm, and these forms are almost impossible to make with cardboards. So it's very useful to have a machine in-house for different projects. And now they have their own 3D printer in Umeå also. So, and my colleague who works with this, he told me that they really use the model all the way through, even in the building site. So it was a good way of communicating with the 3D printer models. Here is another bigger scale project. It's an idea project. I have it here. The scale was big, and we had to divide it into 4 pieces. So yeah, it's different ones, because we want to have it this exact scale to see the details. And in this case, it's in Vårberg. The idea was the whole area is not that safe, and the idea was to increase the quality of urban spaces and have diversity of apartments and ownership. It's both residential and commercial, but as I said, it's an idea project. But the first time clients see those in the table, they become very excited, and this next time they want to, they are also like proud of what they're building when they have it in their hand. So now they order two more of these ones, and the first time it's we offer, and the second and third they pay even 4 times, and for the material they pay for the model. So I mean, they want to have it to talk to go further. Here's another picture of it from another angle. Yeah. And then we made a base to have it as one piece to carry easier. The next one is a Slussen bus terminal. This is a detail project, another scale, and then the idea was to see the, I have it here, to see the the proportion of it. It's a bus terminal underneath Katarinavägen, or inside the Katarinaberget actually. And the purpose is to enlarge the capacity of city communication and connection to buses in Nacka. And in this case, we could investigate also the limitation of the machine, because you need to know how precise you can build with your machine. Because, for example, here we have very tiny openings on the roof, and it turns out very good because we want to have the bigger scale, 1:100. And we printed with support material, PVA. Maybe you know it's dissolvable with water. This Ultimaker T, it has 2 nozzles, 2 extruder, and it was full with PVA, which is dissolvable. And it was in the water for 3 days, maybe. But it turns out okay with all those details. Yeah, here is another picture of it, the gate. It's gates between the main waiting hall to the bus traffic area. And then we have this small group at the office working with Grasshopper and Rhino, maybe parametric design, maybe many of you or some of you have heard of it. So to convince other colleagues or the ledningsgruppen, like the bosses, to have more budget and develop this, it helps us to communicate. Because if you show, for example, the interface of Grasshopper, maybe it's a bit scary with all those wires and stuff. But we did these small test models to show what we can do with parametric design tools. So it was also a good means of communication internally. So yeah, that was it. Try it. I think you'll like it if you haven't tried yet. Yeah, thank you. Questions?
Thank you.
Maybe?
Thank you, Negar. And thank you, Jonas. We have some time for some questions, if you like, both to Jonas and Negar and our as well, but we'll hang around here as well for some time.
I also have 2 models with failures, if you're interested. It can be, yeah, you have it, Erik. Yeah.
So any questions regarding anything today? Nothing? Then we'll just mingle around and look at the printers
I can
and
just
models.
add one more thing. I think these guys, Shannon and everybody here, they are really helpful. I mean, I called them many times, even like 5 to 5 when they finish at 5, but they really answer really good and they help a lot. So yeah, all the technical questions you can ask them. Thank you.
Thank you. Yes.
Thank you everyone for listening. I just want to say, please stick around, ask us any questions you might have. And also might be interesting to know that in the part of the showroom here, we actually have all technology families represented. So for example, for some projects for customers that might want to use a lot of models to hand out to customers, we might choose another technology than desktop 3D printers. For example, for Oscar Properties, we printed a lot of little models of their project Gasklockan, which was then used, we used SLS technology, a powder-based machine, which is really a huge machine in factories. So I would say that for most use for the conceptual models, it's excellent for desktop 3D printing, but it could be good to know that there are alternatives which has different textures and also different sizes possible. So, and we can help out with the design of it or adaptation for 3D printing for a particular technology, because there might be different wall thicknesses or things like this. So please ask any questions you might have and have a look around. Thank you.